Is BlockDAG just a faster blockchain, or is it fundamentally different? Today, we're taking an engineer's perspective to analyze why BlockDAG may solve some of blockchain's toughest scalability and security challenges, and where it still falls short. Let's compare these two from a technical and architectural lens. 1. Structural differences. Traditional blockchains are linear. Block n+1 follows block n. Simple to verify, but inherently sequential, which becomes a bottleneck under high load. BlockDAGs, like in Caspa or Phantom, allow parallel block creation, forming a directed acyclic graph. That means multiple blocks can be added concurrently without waiting for others to finalize. This decouples throughput from latency. BlockDAG wins in concurrent write capability, vital for scaling TPS beyond Visa-level workloads. 2. Consensus handling. In blockchain, e.g. Bitcoin, longest chain rules dominate. When two miners produce blocks simultaneously, one becomes orphaned, wasting effort. BlockDAG protocols, such as GhostDAG, used by Caspa, avoid this waste by ordering all blocks, even if they're mined at the same time. This reduces block discard rates and increases mining efficiency. Key takeaway: BlockDAG networks don't discard competing blocks. They reorder and include them, increasing block inclusion ratio and reducing energy waste. 3. Finality and latency. In Bitcoin or Ethereum, finality is probabilistic. You wait for 6+ confirmations. Ethereum 2.0 introduced checkpoint finality via Casper FFG, but it's still dependent on validator honesty and time delays. In BlockDAG, especially with 1 block per second protocols like Caspa, you get near-instant probabilistic finality, with transaction inclusion happening in seconds, and confirmation scores updated on the DAG dynamically. For use cases like real-time trading or IoT microtransactions, this is a game changer. 4. Security trade-offs. Here's where it gets nuanced. BlockDAGs need to carefully design their consensus so that parallel block inclusion doesn't open attack vectors, like double spending or hidden chain attacks. Caspa's Phantom GhostDAG protocol uses K-cluster coloring to resolve this. It ranks blocks based on the heaviest subgraph, not just longest chain. Phantom uses ABFT, asynchronous Byzantine fault tolerance, via Lachesis, where validators agree on DAG events asynchronously. Both add complexity, but are built for asynchronous trust, something traditional blockchain consensus like Nakamoto consensus lacks. 5. Throughput and bandwidth cost block. DAG enables insane throughput. Caspa aims for 100+ blocks/sec, theoretically reaching over 10,000 TPS. But the trade-off? Increased state bloat and bandwidth requirements. Every node must download and track more blocks, leading to potential centralization pressure unless solutions like pruning, sharding, or fast sync are implemented. Solutions like DAG pruning and L2 rollups on DAGs are being explored, but not fully battle-tested yet. 6. Smart contract integration. Ethereum and Solana dominate due to EVM compatibility and developer tooling. Caspa currently has no smart contracts as of 2025, although plans are underway. Phantom supports Solidity via EVM, but latency issues arise in high concurrency environments. This is where blockchain has an edge: tooling and ecosystem maturity. Conclusion: BlockDAG solves structural limitations in blockchains around concurrency, latency, and orphaned blocks. But it introduces new complexity in consensus and validation logic and still lags in smart contract support. For high-throughput transactional systems, like micropayments, gaming, or financial settlement, BlockDAGs might win the scalability war. But for general-purpose smart contracts, blockchain ecosystems still lead, for now. If you're building for scale, understanding these trade-offs is mission-critical. Outro. Thanks for watching this deep dive on BlockDAG versus blockchain. If you enjoyed this kind of technical breakdown, give this video a thumbs up and subscribe. What's your take? Is BlockDAG the future of scalable ledgers or an overhyped DAG maze? Let us know in the comments below. Stay tuned. In the next video, we'll dive into Caspa's GhostDAG protocol and how it works under the hood.